In this video, I'm going to talk about how to use the kinematics model to solve problems involving motion. So what I'll do is here, I'll take an example of a car that's traveling. We'll actually start at rest. So it starts at rest. Its initial velocity is 0. So I'll say initial velocity, or V0, is 0. The subscript 0 means that 0 times 0. So if I had a stopwatch and start a time equals 0, my velocity is 0 meters per second. What I'm going to have this car do is I'm going to have it accelerate at 3 meters per second squared. And what does that mean again? It gains 3 meters per second every second. So after 1 second it's 3, after 2 seconds it's 6, and so forth. So I'm going to accelerate for 3 meters per second squared, and I'm going to have it end up over here, wherever that's at. And I'm going to say that the car travels 10 seconds during this whole time frame. This time frame is 10 seconds. So what I want to do here is I want to find actually how far the car travels. I'll call that x. And what is its velocity here, knowing that it starts from 0. So car starts from 0, accelerates at a rate of 3 meters per second squared for 10 seconds. How far did it travel, using the front of the car as a reference, and what is its final velocity? So find A, how far it travels, and B, its final velocity. So for a kinematic type problem, we have a straightforward format. In the solution part, there's 3 steps. There's a list equations. So our first equation is this one, x0 plus v0 times t plus 1/2 at squared. V is equal to v0 plus at, and v squared is equal to v0 squared plus 2a x minus x0. So I list all 3 equations every time. I don't try to figure out anything at this point. I'm just listing. This is accounting. I'm just doing some accounting work, making sure I have everything there. Step 2 is my list of variables. So I list the variables in this order, and this is the order. I'll check it in homework. x0, x, v0, v, a, and t. So distances or displacements, velocities, accelerations, and time. So I go down the list here and I see what I have. In every kinematic problem, when we measure distances, the beginning point is x0. And that's like the beginning of a ruler. If I put a ruler on the ground right here, if I overlaid a ruler, just put it on the floor, right here's a ruler, I put that ruler right where the motion begins. So that's 0. That's the 0 measurement on the ruler. So 9 times out of 10, that's going to be 0, because that's where you put the ruler. The only time it's not going to be is when you have 2 objects, maybe 2 cars that are racing, and one is has a head start. Its x0 would be somewhere over here, like 10 or something like that. Otherwise, it's 0. How far does it travel? I don't know. I leave a blank. What's its initial velocity? It's 0 meters per second, because the car starts from rest. What's the final velocity? I don't know. We got to find that out. But I do know that it accelerates at a rate of 3 meters per second squared, and it takes 10 seconds to do it. So those are my variables. Once I know the equations and I have my variables, then I can start solving for things. And one of the things I like to do is just cancel out things that are 0. So anytime I see x0, that's gone. That's gone. My v0 is also 0, so I can get rid of that. Any term that involves a v0 can go away. And that helps me see what I can have to work with a little bit better. Let's see, part A, I'm trying to find how far the car travels. Well, let's see, I have an equation here with x in it. Do I know A? Do I know t? Yes. So I can actually use this equation right here. This one at the bottom here, we know A, but we don't know the velocity, ending velocity. But you can probably see I can solve for it here and then use it there. However, that's a 2-step process. This is a little more easier. However, this would give us the exactly correct answer. X, using that first equation, x equals 1/2 at squared. I get 1/2 times 3 times 10 squared. So that's 100 times 3, 300. So that's 150 meters. And you box your answer. And that's how far the car travels, 150 meters. B, how fast is it going after this 10 seconds? Well, looks like the second equation will do it for us here. So V is equal to AT, which is 3 times 10, which is 30 meters per second. So after accelerating at a rate of 3 meters per second squared, I attain a velocity of 30 meters per second. Now, after this 10 seconds, it may keep accelerating and so forth, but that's something that happens beyond the 10 seconds. So we're only concerned with in this problem from 0 to 10. And that's the basic format of a kinematics problem. Nice diagram to list where variables are so we can visualize the problem. Clearly denote what we need to find. And the solution part is 3 steps. List the equations. Just list them all. We're not trying to figure out the problem yet. Just list them all. We list the variables. So we're taking information from the given down here. And this is basically the physics of the problem. This is finding out what information goes where is the physics. Taking the information and looking back at the equations, or the accounting part, taking the variables and going back here, this is the math part of the problem. And those are the steps to solve a kinematics type problem.